Yes, sir.
Okay. So welcome to this Solve with Instructor session for week 3 and week 4. I hope week 1 and week 2 was good. Any feedback on week 1 and week 2? Or we can move ahead with Solve with a session of week 3 and week 4. Okay, so no reply means we can move ahead, I think. Any issues in this week, week 3? Is my screen visible?
Yes, yes.
It's visible.
Okay. Okay, so let's move ahead with the questions if we have nothing to discuss.
So I have some point to discuss, but that belongs to week 4.
Okay, week 4. Okay.
Week
So
3 and 4. So I will take it a little later.
Okay, fine. Okay, give me a minute. I am facing some issues with my headphone connections. Okay. So let's see first question. This is the question number 1. I hope you people are okay with finding rank, right? Question is visible, right?
Yes, sir.
Yes, so please go ahead and solve. I'm giving you 2 minutes for this. I want answers in the chat box. I've got only one answer from Saktivel. 2. Any other answer? Okay, Yusuf too. Okay, so everyone is getting 2 as an answer. Anything, any other answer other than 2? I think this was a trivial question. No issues in this. You have to just do row reduction to get answer. One of the rows will become completely 0. So rank will be 2. And computation that do you completely your own. In whatever way you do, one of the rows will become 0. The rank becomes 2. Okay, let's move to question number 2. So there are 3 matrices X, Y, and T, and their dimensions are written as subscript. So X 4 cross 3, X has 4 rows and 3 columns, Y has 4 rows and 3 columns, and T has 2 rows and 3 columns. So you have to find what is the order of this whole given expression. No doubt in the question, right? So go ahead and solve. Giving you again 2 minutes. So Pooja, can you unmute yourself? Okay, peer deck. So peer deck, uh, I could not put these slides on peer deck. So we will be following this. Answers will be typed in chat box, and I'll be showing you questions on here. Anyone having doubt in finding this order? 2 cross 2 is the right answer. Anyone who has got any other answer? Feel free to ask questions if you have any doubt. Anyone who is lagging behind? Okay, so the inverse part. See, for this, if you see this bracket, X transpose Y, so X is of order 4 cross 3, right? So X transpose will be of order 3 cross 4, right? And Y is of order 4 cross 3. So if you see this, this is X is 3 cross 4 and Y is 4 cross 3. So after doing this multiplication, what is left? 3 cross 3. And for a square matrix, whatever is the order of the matrix, inverse is of the same order. Or you can say we cannot find inverse if we don't have a square matrix. Inverse is not possible. So since X transpose Y is a 3 cross 3 matrix, its inverse is also 3 cross 3, given that it is invertible. I hope I have cleared your doubts, Srinivas. Okay. So I think you can very well now find out. So P is 2 cross 3, then X transpose Y inverse is 3 cross 3. So what remains here? 2 cross 3. Then P transpose will be 3 cross 2. So 2 cross 3 and 3 cross 2 will be 2 cross 2. And if you transpose it, it will be again 2 cross 2. So this way you have to find the answer. Okay. Let's move to the next question if you have no further doubt. Okay. This is question number 3. The dimension of null space of matrix A is. I hope you people know what is dimension of null space, dimension of column space, and row space. I already have an answer in chat. Shaktivel has written 1. Anyone who has got answer other than 1 or having problem in solving this question? 2. Okay, Pooja, how you got 2? Can you unmute? I'm audible, right?
Yeah, you are.
Yeah, so I'm seeing only one answer as 2. I just wanted to confirm how it is 2. Okay. So your mic is not working. So answer is 1. And how to go about this question? I think most people know how to go about it. There are different ways. One thing is you can find the null matrix for this A by using Ax equal to 0 and then find the dimension. The other way around is, which is the easier way, find rank of this matrix A. Okay. So whatever is the rank, so if you see this matrix, I guess. Okay, if you add R2 to R1, R2 to R1, you will get 1, 0, 1. And R3 remains -1, 0, -1. And then if you do R2 plus R3, then you will get 1 row completely 0. So rank here is 2. And number of columns, I guess, is I'm not guessing it's 3. It's evident it is 3. So rank plus nullity is equal to number of columns. So from that you can find nullity, and nullity is nothing but dimension of null space. So it is 3 minus 2 equal to 1. Let's move to question number 4. Now this should take some time. Maybe you can take 3-4 minutes, solve it. If you have doubt in question, do ask me. Are you able to follow the question? Doubt in the question? Anyone?
Sir, I didn't get the question. Actually, I got the question till R3.
Okay.
The latest part, the vector you can be expressed as. I couldn't get that one.
Okay. So see, what it is saying, this V1, V3 form an orthogonal basis. So if you understand basis is something, any coordinate point that you have on a coordinate system is a linear combination of the basis vectors that we have. So it's a 3D real space R3 having this V1, V2, V3 as the basis vectors. So you have to find combination of V1, V2, V3 such that it is equal to U. Now this combination can C1, V1 plus C2 V2 plus C3 V3 equal to U.
Oh,
Now
we
you
have to
can
find that C1, C2, C3, right?
correct. Very good.
Yeah, okay, got it now.
I already have an answer in chat box. Yeah, I won't tell you the correct answer. I'll tell you the equations which you have to solve after everyone tries and just either answer or get exhausted. People still trying.
Yes, sir. I'm trying.
Oh, go ahead, go ahead. Go ahead. 2 more minutes. We'll go to the answer at 2:19. I have got answers from 1, 2, 3, 4 people, and all 4 are exactly matching. One different answer. So one more different answer. Good. Okay, so people still, are you trying or shall we move ahead to the approach of solution? You can even try and let me know. Achha, theek hai. Then we will move to the approach of the solution. So see, if, okay, I have got very different answers. So I think the first 4 answers are correct. Why I'm thinking so? Because I have solved it and I have got 11 by 5 as C3. Rest 2 I have not solved, but 11 by 5 I got. So it's like, see, what you have to do, you have to just do C1 V1 plus C2 V2 plus C3 V3 equal to U, right? So now you will be dealing with 3 set of equations. Okay, so first equation will be the first element of V1 into C1 plus first element of C2 into, first element of V2 into C2 plus first element of V3 into C3 equal to first element of U. Similarly for other elements. So my first equation will be C1 plus 0 C2 minus 2 C3 equal to 4. Basically C1 minus 2 C3 equal to 4. Second equation will be, since we have 0 in V1 and 0 in V3, we will be having C2 equal to 3 directly. So if someone has not got C2 equal to 3, it's wrong then and there. So C2 should be equal to 3. Next, 2C1 plus 3 equal to minus 3. Now you have to solve these two equations. Which one? First equation is C1 minus 2C3 equal to 4. And second equation is 2C1 plus C3 equal to minus 3. Solve it, you will get the answer. So if anyone has solved any other equation, they are wrong. Got the approaching? Those who have got it wrong. Maybe I will be randomly asking Kirti, S. Kirti. Okay. So those who have solved C2 equal to 3 and then C1 minus 2, C3 equal to 4 and 2 C1 plus C3 equal to minus 3 are right. Okay. And then let's move ahead to the next one, question number 5. So there is a matrix which is 7 cross 9 and has rank 5. Then I have to find the dimension of row space, column space, null space, and left null space. I think it should not take a lot of time, take 3 minutes. At 2:25 we'll discuss. Yes, Srinivas.
Sir, although the answer is clear, if you could just once explain all the 4 terms after the answer.
Sure, I'll explain.
All the answer is more or less clear.
Okay, I'll explain.
And also, sir, the difference between the terms in terms of a matrix and in terms of a linear transformation also.
Okay, I'll try to explain.
Sir, also the use of left null space.
Okay, fine. Anyone else who is trying the numerical part of the question? Okay, so let's first understand the numerical part, which is very easy. So first thing, we have the dimension of matrix is given. It is 7 cross 9. It means A has number of rows 7 and number of columns 9. Then rank given is 5. So you can very well from this rank you can write directly the dimension of row space is 5 and dimension of column space is 5. Because rank is nothing but dimension of row space and dimension of column space, which are always equal. So one of the person, I think Vipin wrote it 4. So I think you should know this, that dimension of row space and dimension of column space are always same as this is equal to rank. Okay. So the first two answers are 5, 5. That's for sure. Then dimension of null space. How will you find dimension of null space? From rank nullity theorem. That is rank plus nullity equal to number of columns. So rank here is 5, then column here is 9, and nullity you have to find out. So nullity will be 9 minus 5, which is equal to 4. Then what about left null space? For left null space, the formula becomes the rank plus dimension of left null space, which is equal to number of rows. So it will be equal to 5 plus dimension of left null space equal to 7. So the answer will become 7 minus 3 of 5, which is equal to 2. So the correct answer is 5542. Okay. Achha. Then the next part of the question, I have this row space, column space, null space, and left null space. Basically, these are you can say identifier of a given matrix. So how can you define a particular thing? By different features, right? So for a matrix, this row space, column space, null space, and left null space put together and their properties make that particular matrix. Okay, that is the physical significance of all these 4 fundamental spaces. Next thing, what these dimensions have to signify? See, dimension of row space and dimension of column space give you rank. Okay, so every property which is related to rank. For instance, if rank of a matrix is less than number of columns or number of rows, then it is not invertible. And if it is not invertible, then Ax equal to will not be solvable. Such properties are derived from this row space and column space. Okay, so these are the use cases.
Sir, can you repeat the invertible statement again?
So see, if there is a 3 cross 3 matrix, okay, and your rank is 2, it means one of the rows is completely 0 when you reduce it to echelon form. Okay. So for such matrix, you cannot find inverse. So if inverse is not possible, then Ax equal to B is not solvable because A goes to the other side, right? Ax equal to B. So for that you need x equal to A inverse B. So if A inverse is non-existent, then sorry, A inverse is not existent, then A inverse B is non-existent. You cannot solve such equation. Got it?
Just to summarizing, sir, if the rank of the matrix is less than the number of columns of the matrix, it implies that the inverse is not possible. Is that what your statement is?
Yes, yes.
And your audio is very low, sir. We are having to hear very less.
Okay, okay. Give me a minute. I'll increase the volume. Is it better anyway?
Only slightly, sir.
Okay, on my side it is full volume. Maybe I'll speak louder. That's the thing. Am I audible?
Yes, sir.
You are audible, but voice is low.
Okay. Maybe I'll increase volume. Is it better now? Better, right?
No, sir, it is still low.
Okay.
So we'll continue, sir. We'll put in speaker and we'll continue.
Sir, I don't understand this left null space and row space because I am not able to visualize like the thing I can able to see the correlation between for the column space and null space.
So also if you would explain the null space also.
Okay. Okay. Any better volume? Hello.
It is okay, sir. You can please proceed.
Okay. So the technical part of it, sorry for the inconvenience due to mic and this speaker. Even I am not able to figure out because on my side it is full. Okay. So coming to the question, this first thing we were discussing the inverse, right? So that part, if the rank of a matrix is less than the number of columns, then inverse is not possible. That you should remember. This is because the determinant is 0. So if determinant is 0, then inverse is nothing but 1 upon determinant adjoint of that matrix. Correct? So if determinant is 0, then 1 upon 0 is non-existent. So that means inverse is not possible. Next, can you please?
Sir, determinant is only possible for square matrices, right?
Correct.
But rank can be for any type of matrices, right? Not only for square matrices.
So when I am saying inverse, okay, when we have inverse, then I am talking about square matrix only, right? I cannot have an inverse for 2 cross 3 matrix.
Okay.
Got it? Okay. So that part I think clear. Then next questions. Can you please repeat again?
Sir, I do not understand this row space and left null space because the way I can able to correlate and visualize the column space and null space, I'm not able to figure it out the row space and left null space.
Okay. So see, these are nothing but the counterpart. So whatever you can do from column space, you can do from row space. So if you are clear with column space, then row space is just a substitute of that. Keep that in mind. Similarly, not substitute, actually complementary of that. And left null space is complement of null space.
No, this part is not actually not clear, sir, because the column space, that what I understood, all the solutions is lies in that plane. Suppose one of my solution lies in one plane, then I can able to visualize that plane, and in 3 dimension I'm talking about, and I understand all the vector which can span by this matrix lies on that plane, so that I can say as a column space because all the solution is lying on the column space. In this way, I understand the column space.
Yeah. So
and
what will be row space? Row space will be transpose of that matrix into X equal to B as solutions.
Why we are taking transpose then means what is the significance and use of this row space?
So if you go ahead and go on solving, you won't find that significant application of row space, to be frank. If you are clear with column space, that's all.
Just transpose of that, and
it's just a mathematical definition. I mean, for the sake of completeness, we are studying everything. But if you're clear with column space, null space, that's it.
okay.
So basically, whatever. So for instance, if you want to find rank, so rank you can find using column space, right?
Hmm.
estimated rank you can find using row space.
Yes.
So you do the similar thing with these complementary fundamental spaces.
Okay.
So any other doubt?
Sir, null space.
Yeah, null space is that particular space where the solution of AX becomes 0. So basically it nullifies AX. Therefore, it is called null space, where the solution becomes 0. So basically you can say it can be a boundary between where AX goes positive and AX goes negative. So it's the midpoint where AX equal to 0. Clear?
Sir, if you say the null space is the set of all vectors from in the given vector space when transformed or moved to the origin, would that be a right statement?
Yeah, you can say when a given vector is linearly transformed by that particular matrix and it goes to
we have the
origin,
state.
and given that your origin is 0, 0, 0.
Ax is equal to 0 is our Ax is equal to 0 is our equation.
If you're considering your origin is 0, 0, 0, then your statement is true. But if the
There are-
origin is not 1, then it is not true.
But there are other cases we consider origin as other than 0, 0, 0.
Yeah, there are cases where you can start from 1, 1. So you can start from 1, 1, 1.
But when we say Ax is equal to 0, we are trying the linear transformation, sir. For a linear transformation, the base case is origin must be present, right? 0, 0, 0.
Yeah, correct. I mean, so reference can be anything. So if frame of reference, if you consider, no. So if I'm saying most of the things in physical world are relative. So if you are saying from 5 to 0, it is 5 units. If you are saying from 6 to 1, sorry, 5 to 0 is 5 units and 6 to 1 again 5 units. So in relative cases, it doesn't matter. But in absolute cases, it matters.
When I'm saying Ax is equal to 0 is my equation, right? So A I am considering as my linear transformation. X is the set of all vectors, either unique or it might be multiple set of vectors. All
Correct.
these vectors after the transformation are being moved to 0, right?
Correct. I'm completely agreeing to your statement.
For this linear transformation to occur, we can be only at 0, right? We can't be at origin should always be at 0. There can't be an origin which is non-zero, right?
Yeah, in this case, yes.
And
Sir, can you proceed now?
is the null space of a matrix different from a null space of a transformation, or both same items?
Null space is only considered for a matrix.
Okay.
It's not for any transformation. Okay. So any further doubt or we can proceed? Someone said me to proceed. No doubt, right? Okay. So let's proceed to the next question. So this is an interesting question. Go ahead and solve it. I'll give you 4 minutes to solve it. If anyone doesn't follow the question, you can intervene in between. have got no answer in chat yet. Okay, 1 extra minute, maybe 2:43. One answer from Kamal I have got. Now there are many answers. Vipin, can you unmute yourself?
Yes, sir.
Yeah, can you tell me how you did this question? Approach.
Right. So we have a ground and we have a stick, right? So there will be shadow of the stick on the ground. So simply means that we have to find the projection of the stick onto the ground. So we have, we have a vector u, which we have to find the projection for, and vector v, which we have to find the projection onto. So the formula is simple.
So what is the formula that you have used?
Yeah, the formula. So formula is u dot v by norm of v.
Norm of?
Norm of v.
Norm of v. I think your answer is wrong.
Sir, I don't think that I should have. Do I have to divide it by norm of v? That I
Norm
can
of-
directly do u dot v, right? That will give me the projection of u on v, correct?
Then?
And then I can my answer is, so 5 times 2, that is 10 I cap and 3 j cap, and then I'll take the.
Why we divide by norm of v? It's because we want to bring everything to the same scale. So you have to divide by norm of v.
Ah, okay, got it. Sir.
Maybe we have to multiply it then as well with
Yeah,
this.
you have done that wrong. So that's why I pointed you out.
Okay.
Okay. So be careful about that. I think Mohammed Faizan Ali has also done it wrong. Then Kamal Kishore, I think, is right. Pranav Vandekar, do it more. You cannot give an answer like this.
So can you please explain also that why am I dividing it by norm of v, please? I'm kind of confused on this part.
Yeah, so when you are finding dot product, what exactly you are doing? You are doing component-wise multiplication, right?
Correct.
Yeah, when you are dividing it by norm of v, it means you are bringing it to v space. Okay, with respect to v kitna hai? That is what you are doing.
But sir, okay. If I just do so in terms of I cap J cap, correct, sir? So u dot v I'm doing, that will also give me a projection. So u dot v I'm doing, so that will give me projection of u onto v directly.
U dot v and v dot u do not give projection. They are scalars.
Okay, sir. Yeah, got it, sir. Got it.
They are scalars. They are not vectors. They only give mathematical product component.
Yeah, sir. I square will be 1. Yeah, got it, sir.
Okay. Then next, okay. So yeah, for this particular case, you have to use the formula for v transpose u divided by v transpose v whole into v, because you have to find the projection of stick on ground. Okay. So Ajit, again, your answer is also wrong. It should be 2.55. So if you do P equal to V transpose U divided by V transpose V into V, you get a vector phi 1, and which is multiplied by half. Now what that vector, if you find it length, then you get the length of the shadow. Okay, so I think one person, Pranav, the answer that you gave is correct, but you have to solve it to numerical value. So Ajit, can you unmute yourself?
Yes,
Ajit
sir.
Kumar. Yeah. So anything wrong in calculation or approach?
Sir, calculation mistake.
Okay, fine. Approach is correct, right? Approach, you got it?
Yes, sir.
Okay. Anyone else having any doubt, or shall we move ahead?
Sir, I just want to confirm. So the final formula will be u dot v by norm of v into v, right?
Yeah, correct. That will be projection. Now you have to find the length of each combo, the vector that you get.
Okay. Yeah.
Because they have told you to find the length of the shadow. So you have to find the length of the projection that you get. Okay. So let's move to the next question if we have no further doubt. Again, this is a very easy question. Go ahead, solve it in 2-3 minutes. Okay, so it is computation intensive. Maybe I'll give you 1 more minute. Solve it till 252. Anil Srivastav, can you unmute yourself?
Yes, sir.
Yeah, how you got 1.67?
Sir, first of all, I have calculated the projection matrix. Then I have.
For what? U or V?
Hello.
Projection matrix. Yeah, you are audible. Projection matrix for U or V?
Just a minute, sir. Projection matrix for A.
A. So what is your A?
A is -1, 3, -2, 1. This vector.
Acha,
and
so you are.
Yes, sir.
Question number.
Yes. The projection matrix is.
Wait,
one.
Question number 7 already.
Yes, sir. Actually, I solved before coming to the session. I attempted all the questions.
Okay. Then I thought you are doing it for question number 6.
No.
Okay, fine.
So it's a 4x4 matrix, and then.
Yeah. It's fine for this question. I thought it is for the previous question. Any other answer other than Anil?
Yes, sir. I am also getting the same.
Okay. So this is the easy question actually.
Yes, sir. But really calculation intensive.
Calculation intensive, sir.
Yeah.
Correct. So you have to deal with calculation sometimes.
Yeah.
Mathematics without calculation is nothing. So I think most of the people are like they don't like calculations and all, but you will realize this, and you may have realized this already. Calculations are very important.
Yes, sir. Yes, sir.
No one should be bothered about it. That's
Sir,
why the
actually,
question.
what has happened with the use of a spreadsheet and all those things, we just simply plug in the values and put the formulas, the value, the output comes out. So that manual calculation part, day by day, we are just skipping it.
Skipping, ignoring, but that is very important.
Even with the help of coding, we are just skipping all this thing.
Yeah, correct. But while doing mathematics and a subject like this,
Yes, sir.
just come back to the ground.
Sir, पूरा feel आता है.
Yeah, correct. आना भी चाहिए.
Sir, can I ask you something else?
Yeah, please.
It's related, but see, I'm not used to this terminology error vector, but I know the vector calculus actually. So I'm asking, sir, is this that sign component of that projection? Like, if I project B onto A, so there will be a.
You are right. A sign component. Yeah, the perpendicular.
Okay. It should be easier to calculate, right? By that logic.
No, but go ahead with this particular thing, because sign component you can find when you have small vector. You have a small situation. But if you have a 5x5, 6x6 matrix, what will we do? You have to go with this particular approach. So this is
Got it.
portable.
Got it, sir.
Yeah. Okay, so this problem is simple, I guess, except for the calculation part. So what you have to do, first find projection matrix. Projection matrix is, you already know the formula. It is A transpose divided by A transpose A. So find A transpose divided by A transpose A. That will give you full matrix. Then multiply that particular projection matrix with B. So you will get in a 4x4 matrix. 4x4 matrix or 4x1 matrix? 4x1 matrix.
4x1 matrix.
4x1 matrix.
Yeah.
Then you have to do P, this already given B minus jo projection you have find out, PB.
Yes.
B minus
yes.
PB.
B minus P.
So that will give you error vector. Now find it link.
Yes, sir.
Anyone is having any difficulty in the approach? Please ask. Feel free to ask questions.
Sir, can you repeat the formula?
Yeah. I'll repeating step by step. First, find projection matrix P, which will be equal to A transpose divided by A transpose A. This is my first step. Okay. Next. Second step is multiply this projection matrix P with B. So you'll get PB. That will be a 4x1 matrix. So this is step 2. Third step is find B minus PB. B minus PB will give you a again 4x1 matrix, which is a error vector. Now next step is find the length of this vector. Okay.
Yes, sir.
Any other doubt? Anyone? Well, I'll randomly pick people and make them speak. Okay, so can we move ahead to the next question if we have no further doubt?
Yes, sir, I guess. No.
Yeah, okay. So this is a interesting question. Acha, so best fit line for the given data set, it will take a lot of time. Yes, it's good to find it out. So you people want to solve it or?
No, sir, it's easy.
Yeah, so you know the approach, how to solve it. Anyone can please explain? How will you solve it?
Linear regression.
So first of all, we'll tabulate the data.
Correct.
Then using the approach AX is equal to Y, we'll assume that the coefficients associated with this
Okay,
are
now,
theta
now
and
my
theta
question
dash.
is, what is A?
A is it's a 5x2 matrix where column are 1, 2, 3, 4, 5, and second column is 1, 1, 1.
Okay.
Then we have
Second
theta.
column. If I take first column as 1, 1, 1, 1,
Then we will interchange, sir. If we'll put then theta double dash first.
okay, correct. So this is where most people get confused. Very good. So if we put 1, 1, 1, 1, 1, wherever we put, if we put it at first column, then my intercept will come as the first answer. And if I put it in second, then my intercept will come in second place.
Equation
So
comes like y is equal to theta naught plus theta 1 x. So if we put theta naught first, then accordingly 1, 1 will come. If we put as x theta naught, theta 1 plus theta naught, then accordingly the matrix will change.
This is very important. So if anyone is having this doubt, please do ask.
Sir, can you show us?
Yes, sir. Even I have.
Can you go through the method?
Yeah. Okay. So.
Particularly this point only.
Yes, sir. This method only.
Okay, correct. So actually, I don't have any writing material right now, but I will surely tell you. So suppose okay, let me take this only. So if I tabulate it, can you write with me while I speak?
Yeah.
Right. So just write the coordinates of A, B, C, D, E. There are 5 points, na? A, B, C, D, E.
Yes.
Okay. Now A what is the X and Y for A? 1, 2. Correct?
Yes, sir. 1, 2. Yeah.
It is 2, 1. For C it is 3, 3. For D it is 4, 4.
Yes, sir.
And for E it is 5, 4.
5, 4.
Okay.
Yes.
Now suppose I want to write the matrix A.
Yes, sir.
So matrix A is what? Matrix A consists of all the X's and a dummy column, which is 1, 1. Correct?
Yes, sir.
Okay, Ajit, I'll come to your question. Okay, let's first finish this up. Okay, so suppose you write the first column as 1, 1, 1. Then your matrix will become 1. I am going column wise. 1, 1, 1, 1, 1. Then 1, 2, 3, 4, 5. Okay. Now suppose you find A transpose. वो निकालना पड़ेगा ना, for if you want to find the least square solution, you have to find
yes, sir.
AA.
Yes, sir. निकालना पड़ेगा.
Because you will be doing AA transpose X equal to A transpose B. या फिर A transpose AX. I think it is A transpose AX. It's not AA transpose X.
Yes, sir. It is A transpose AX.
Yeah. So A transpose A. If you think, see, now the answer to his question, who was saying practically how can you do it? So see, if you do 1, 1, 1 first column mein, then your A transpose A will give you answer. If you put 1, 1, 1 second column mein, then your A transpose A will change.
Okay, sir. Yeah.
And therefore, this value of theta naught and theta 1 interchange.
Yeah, because it is interchanging. So yeah.
Correct?
Yeah.
So you had this doubt or anyone else had this doubt?
No, actually I had also, but someone else has.
So that someone else, have you understood?
So if I take it in a little simple way, like since we are fitting the linear curve, so I will take y is equal to theta 1 plus theta 1x, and whatever coordinate you will get, I will write all these things, take the matrix and solve for the theta 1 and theta 2.
Correct. That way also you can go. So you should be consistent with whatever is your approach. So if this suits you, this is also correct. But yeah, so basically what happens, 1, 1, 1, whatever is the position of 1, 1, 1, there you will get intercept. That thing you should keep in mind.
If I take the constant part, intercepted part first, I will
will
follow
get the
for the
constant
same
part.
thing for the rest of the equation.
Yeah, correct. Very correct. So previous question answer was 0.67, I guess. 1.67 someone wrote. 1.65, maybe some calculation. Well, I should run off. Okay, Ajit, after finding the linear equation, how to check which value is best fit out of the sum given points? This is done using matrix like mean squared error or sum squared error. So basically least square method, whatever the equation that you are getting least square. So the method itself is least square. So here the parameter which you are minimizing is least square, sum of residuals, sum squared residuals. So this gives you best fit model in terms of sum squared residuals. Okay, Ajit.
Okay, sir.
Okay. So shall we move to the next question? If there is no further doubt. We can move, right?
Yes, sir. So the best fit line will be 0.7 x plus 0.7, right?
Yeah. Go ahead, solve A transpose AX equal to A transpose B.
Yeah, no, I was solving. That's why I was just confirming that.
So someone has written 0.7 plus 0.7.
Yeah.
Hmm.
So it's correct, right?
Yeah, I think it's correct.
Yeah.
Okay, next question. Again, this is very easy question. Read it, try to solve it. Or at least approach should be clear.
Sir, line 1, I think. Line 1 will be good.
Okay, let us solve it. Then we will find out. Okay. So what is the question? Consider two lines, a line with zero slope and y-intercept of 2.5. So can you tell me what will be the equation of this line?
It will be x is equals to
Y equals
y is
to
equals to
2.5.
2.5x. Yeah.
Correct. Yeah, because it is written y-intercept.
Yeah.
So y-intercept equal to 2.5, and for the next line it will be y equal to 3.5.
Yeah.
Okay, then what you have to do? All these points are given.
Yes, sir.
So just subtract for the first line.
Yes, sir.
Subtract the
Distance from line 1 and distance from line 2.
Yeah. So whichever gives you the minimum is the answer. Matlab for point A, what is the y component? 2. So for the first line, it's 2 minus 2.5. 0.5 is there.
0.25. Yeah.
Yeah. For the point F, it is 2, 1. So for the first line, it is 2.5 minus 1. For the second line, it is 3.5 minus 1. So
Yes,
whichever gives the minimum of those will be the line of minimum error.
Yes, sir. तो लाइक एक रो में लाइन 1 के लिए लिख लेंगे, एक लाइन में लाइन 2 के लिए, एंड देन सम इट अप, और उसके बाद जो लिस्ट होगा.
Yeah, Yusuf, we need to solve in a sense. Yeah, so this particular question is very easy. You can solve it intuitively, but
Yes,
in general, you need to solve
like that.
this method, and that method you will get only by solving.
Yes, sir. Yes. हाँ, ये तो ऐसे ही हो जाए.
Okay, so for this, I think for question, how the session is.
Sir,
that we will
question.
Yeah.
If there were, let's say, x-axis and y-axis, both of them, then we would have solved it with the least square method. Sorry.
Oh, so see, the error is always with respect to the target variable. है ना? Error whenever you are finding, it is with respect to target variable.
Target variable. Yeah.
SWI. You don't find error with respect to the independent variable. Got it?
Yeah.
Sir, so my question is like how would you have solved it in that
So
case?
it's basically a least square question only.
Yeah, right.
So you have to use least square. So you find the error, square it, sum up.
Okay.
Okay. So let's move to the week 4 part now. If we are done with week 3. Any doubt in week 3? Other than these questions that we have solved, I'll try to explain if I can. अच्छा ठीक है, then we will move to week 4. So these are very easy questions. Question number 1, you should be able to solve in 2 minutes. Solve. At 3-9, we'll be having answers. Okay, Anil has already solved it. So Pranav, can you tell me what was the approach that you used?
Hello.
Yeah, Pranav, your voice is king, but
Am I audible?
yeah, go ahead.
So if you see first row and the last row, if we can like use the scalar multiplication.
Okay, we are not able to hear you completely. Maybe I got your answer by the bits and pieces that you gave. So that is one approach, and the other approach is set determinant equal to 0. So set determinant equal to 0 will work. Very fine.
Yes, sir. Yes,
And
sir.
the other approach is just reduce it to row equivalent form. So
Yes, sir.
one of the rows should become 0. So somewhere you will find कि एक element is equal to some in the form of x. जिसको आप अगर 0 से equate कर दो, then your rank will become less than 3.
No,
So that is
sir.
the third approach.
Yeah.
Okay.
So that will be row 1 and row 3, right?
Yeah. So it can be anywhere. Depends on the transformation that you are doing.
Yeah.
But the determinant equal to 0 is the better approach for this particular question. Okay. So let's move to question number 2. This requires some solving, so I'll give you maybe 3 minutes. Solve it till 3:13 or 3:15 maybe. So is it always like this? Few students speak and others do not. Advait, am I audible?
Yes, sir.
So how is the feel like MLF first 2 weeks?
Going well, sir.
Well,
Yes, sir.
able to follow everything?
Yes.
Okay. Who is this AP?
Yes, sir.
Yeah, AP. May I know your full name if you want to?
Yes, sir. My name is Aryesh.
Achha. How is MLF going?
Sir, till now it's okay, but I'm not sure what lies ahead.
Yeah.
Like week 4, it starts to get little tough.
Yeah, correct. It will go on becoming tough till week 7.
Yes, sir.
Okay. Next, is this Afreen? Afreen, are you there? Can you unmute yourself? Okay, may not be there. Ajit, we have already talked. Anil, we have talked. Rahul? Okay, most of the participants do not want to speak. Achha, let's move. Let's move to the question here. So first thing, you have to find the eigenvectors of this particular matrix. How will you do that? Any issues in finding the eigenvectors? Okay, Advait, you got the eigenvalues. So eigenvalues for a diagonal matrix like this, the diagonal elements are the eigenvalues. So it's 1, 2. Now eigenvectors, how to find this? You remember this A minus lambda I. A minus lambda I x equal to 0. This is how you find eigenvectors. You have to find that x for which A minus lambda I x equal to 0. Or Ax equal to lambda x.
So that is only called as a characteristic matrix, no?
Ax equal to lambda x is eigen equation.
No, sir. A minus lambda I. That is characteristic matrix, no?
A minus lambda I ka determinant equal to 0. Is
That
the
is
characteristic. And Ax equal to lambda x is the basic definition of eigenvalues and eigenvectors.
Yeah.
So eigenvalues you will be getting 1 and 2 for this particular case. Now suppose you want to find for lambda equal to, then what you should do? Let me tell you what you should do. You have to do A minus lambda I x equal to 0. Okay, so first find out A minus lambda I. So when you are taking eigenvalue equal to 1, so your lambda becomes 1, correct?
Yes, sir.
So this particular matrix will change to 1 minus 1, 2, 0, 2 minus 1. Okay, x equal to 0. Are you following me what I said? Advait?
Yes, sir. Getting.
Yeah, so it will become 0, 2, 0, 1. 0, 2, 0, 1. Hai? So if you take the first row, it will become 0x1 plus 2x2 equal to
0.
Equal to what? 0. Hai na? And similarly, the second equation is 0x1 plus 1x2 equal to 0. So if you see, 0 is getting multiplied to x1.
Yes, sir.
So whatever be the value of x1, since you are multiplying it with 0, it will always become 0. And x2 will always be 0. So this particular eigenvector will be x1 equal to anything and x2 equal to 0.
Yes, sir. So we can write it P0.
P0, K0, whatever.
Yeah.
Okay, some k0 or p0.
Yeah.
That is your eigenvector 1. For the second eigenvector, again you have to do a minus lambda I x equal to 0. So for the second eigenvector, eigenvalue, which is 2, you'll get 1 minus 2, 2, 0, 2 minus 2. So basically you are getting minus x1 plus 2x2 equal to 0. So if you solve it, you'll get vector as 2, 1.
Yes, sir.
Okay, so your second eigenvector is 2, 1. Now, in what form you require your this eigenvector? 1a and 1b. So the
Yes, sir.
first eigenvector we got, which was
Yeah.
of the form k0, just put k equal to 1.
Yes, sir.
So you got for the first 1a, 1, 0. For the second, since you are getting 2, 1, you have to make it to the form 1b. So what you have to do, just divide the both elements by 2. So you'll get 1 and 1 by 2. So the first eigenvector is 1, 0. Second eigenvector is 1, 0.5. Now add 0 and 0.5. So the answer is
half.
Sir, why did we divide by 2?
Just to bring it to the form 1a, 1b. Because it is mentioned in the question. Your first element should be 1 in the eigenvectors.
Okay, got it.
Got it? Okay.
Yeah, thank you.
Okay. So can we move to the next? Okay, I am getting 1, 2 as one eigenvector. No, it should be 2, 1. Some calculation mistake, Bipin.
Sir, is the first eigenvector 1, 0 or 0, 0?
It's k0. Anything, first eigenvector is no meaning. For which eigenvalue?
For eigenvalue as 1.
For eigenvalue as 1, it is k0. So x1 can be anything.
Sir, how come? Because the equation is like 0x1 plus 2x2 is equal to 0.
Now put
And
x1 equal to 1. In your equation, put x1 equal to 1. क्या मिला?
sir, I am getting both the x1 and x2 as 0 and 0.
0 x1 plus some x2. मतलब what is your coefficient?
2x2.
2x2 equal to 0, correct?
Yes.
Now suppose you put x1 equal to 1. Your equation is 2x2 equal to 0.
Yes.
Put x1 equal to 5.
Okay, so it can be any constant. Yeah.
Correct.
Okay, okay.
So it can be anything. Since you are multiplying with 0. Correct?
Yes, sir, got it.
So
sir, what is the answer here?
okay. So can we move to the next question if you have no further doubt, or are we having some doubt?
Sir, I just want to know the answer to this question.
Answer is 0 plus 0.5, which is 0.5. Correct? Okay. Let's move ahead to the next question. Solving now, all of you. So Bhagyashree, can you hear us?
Hello, sir.
How is MLF?
Going well, sir.
Okay. Himadri Dixit.
Yes, sir.
Good subject, right? Enjoying?
Yes. Easy up till now.
Yeah, up till now. Hopefully you say this after 2 weeks.
Let's see.
Yeah, it will be easy. It will be that tough.
Yes, sir.
Sai Kalyan Rao. I have already got answers in the chat box. -4/5. -0.8. Ayush Kumar, can you unmute yourself? Okay, it's -4/5.
Yeah.
Oh, it's, yeah, it's yes 4/5. Sorry. Correct.
Sir, actually we should find like A transpose is equals to A transpose A is equals to identity, na?
Anyone will do. A transpose equal to I, या फिर A transpose A equal to I.
Equal to, yeah, and which will go the same. But I read somewhere that if we find the dot product of volume vector and that is equals to the 0,
So
that
why there is an issue.
yeah.
What issue? You will get answer 4/5 and -4/5.
Yeah.
Now you have no way to confirm ki sahi kaun sa hai. But if you do A transpose and A transpose A equal to I, you get two equations. So the value which satisfies both the equation is the correct answer. So -4/5 is the only value which satisfies both the equations.
Sir, but I am getting by the dot product also -4/5 only, na?
What? Can you repeat?
Sir, by dot product also I am getting -4/5 only. That's what I'm saying. Yeah.
Okay, -4/5 you got.
Yeah.
But
Like
A transpose equal to I is more.
No, sir, I'm just asking that whether it is right thing to do or not.
No, it is correct. Correct because it's a property of orthogonal matrix.
Oh.
Therefore, it is orthogonal.
Oh, yeah, that's why I'm asking.
Okay.
Because it will be 3/5 into 4/5, and that is equals to 3/5x. So 3/5 will be cancelled out. So x will be equals to -4/5.
Okay. Achha, so anyone having any doubt in this particular question? Any doubt? Okay, let's proceed to the next question. This is a very easy question. Maybe it should take 2-3 minutes. Solve it. Achha, next, Pallavi. Can you hear us? Many people are having the mic or what?
Yes, sir.
So, how is MLF till now?
Sorry, sir.
How is MLF till now?
It's good, sir.
Achha. Good. I have already. Okay, tell me the values of x and y also in the chat box.
10 and minus 4, I guess.
How have we approached this question?
That I found the trace and you have given the eigenvalue.
Trace and determinant. Basically, you have to do this.
Yeah. So trace will be 12.
Trace is equal to sum of eigenvalues and determinant into product of
product.
Yeah. So basically, you will get 2y minus 3x equal to 2 and 2 plus y equal to 12.
So this property holds only for diagonal matrix, right?
Diagonal matrix, no, it is valid for any square matrix.
No, it is for everyone.
Okay, okay.
Trace and determinant wala property is valid for any square matrix. Okay. So I think no doubt in this question or any doubt. Let's proceed to the next question. It is also very easy. Go ahead and solve it. Next person in list is Pooja. Okay, she's having issue with mic, she told. Okay. Pranav, we talk to you. Pranav Sharma.
Yes, sir. Hello.
General feedback. How is MLF?
No, I'm facing up to the mic actually.
Okay, okay.
Am I audible?
Okay. So your voice is breaking.
No, you are not audible.
Okay. Okay, Pranav Wankhedkar.
Yes, sir.
How is MLF?
MLF is up till now it's going good, but in week 4, I think somebody said that it escalated quite quickly. Yeah, so I'm just having trouble with some concepts in week 4. So other than that, it's good. Yeah.
Yeah, so you have to put a little bit of, but it's not that tough. Week 5 and week 6 are little tougher according to my perception, but week 4 is not that tough.
Yes, sir. Till week 4, it's not that tough.
Okay, and there will be escalations. Since you are covering a total mathematical foundation of machine learning in 12 weeks, you cannot expect a smooth ride.
Yeah,
sir, but we have covered the same into the maths 2 and the stats 2 also now.
See, it's about a package. So if you consider machine learning foundation, techniques and practices, they together form a package of machine learning.
Yeah. No, I'm just saying that a lot of mathematical part of ML we have.
In class 7, you read something which you have read in class 6.
Yeah.
Or not?
Yes.
So that's a logical way of dealing with it. See, if there's a subject which is completely alien, then also people will have trouble.
Yes, sir. Anyways, I found. Yes, sir. This is completely.
Okay. Next person, Prash. Am I spelling correctly, Prash?
Am I audible?
Yeah. Yeah, you're audible. How is MLF?
It's fine for me, sir, till now.
Okay. Enjoying?
Sir.
Who enjoys studies, right? But you have to.
No, sir, I do, but not the calculation part. It's so time-taking.
But it's also a flavor.
Yeah.
Okay, so this question, anyone solved?
Yes, sir, done.
How to approach it?
Sir, again, I hit the matrix like.
Form the matrix.
Yeah,
find
form the matrix.
Raised to the power 18.
Eigenvalue. Yeah.
Right. So the eigenvalue I get
plus minus root under 2, I guess.
Plus minus root 2. So if you raise to the power 18, that is the answer.
2 to the power 9.
Yeah. Minus 2 to the power 9 and 2 to the power 9.
Sir, yeah. No, same only, no, sir.
Okay, because it is squaring and then
Yeah.
raising to 9.
Yeah.
Correct. So it will be 2 raised to 9 repeated.
Yes, sir. Even number of parts. So yeah.
Okay. Okay. So any doubt in this? Anyone? Any issues? 512. Yeah, it's 2 raised to 9. Correct.
Sir, the property, what's the property we are using?
We are using for A, suppose the eigenvalue is lambda, then for A to n, the eigenvalue is lambda raised to n. So one more additional property which is very widely used. Suppose the eigenvalues of A is 1, 2, 3. Then eigenvalue A inverse will be 1, 1 by 2, 1 by 3. Because it is raised to minus 1.
Oh, yes.
Okay. Chalo, so let's move to the next question if we are having no doubt in this. Solve it. I'll give you maybe 3 minutes to solve it. 4 minutes. 3:37 will come. So we have talked to Prash. Next, Pratik Singh. Mic issue, is it? Pratik Singh. Okay, Preetodeep Dev. Preetodeep Dev, are you there? Okay, Ragini.
Yes, sir.
So how is MLF?
Yes, sir. It's easy.
It's
Up
easy
till
now?
now. Yes, sir.
Very good. This is how we should be seeing a subject. Easy.
Yes, sir. Yeah.
Okay. Fine. Okay, I got one answer. Answer 17 from Ayush. Ayush, can you unmute yourself?
Yes, sir.
What is the approach?
Sir, I did AX is equals to lambda x.
Ax equal to lambda x. Okay.
Yeah.
Correct. So
Right.
Ax, how many variables now you have? Ax equal to lambda x. Mein?
There are two variables.
One will be p and other will be lambda.
Lambda. Yeah. 2
So you
lambda
have
is
to
equals
solve.
to 10. Yeah. Yeah.
Correct. Correct. Any other
Sir.
approach anyone used? Yeah. Yeah. Anyone saying?
No, sir. I was saying only कि आप मुझसे नहीं पूछे कि MLF कैसा है. So I was saying.
Sir, I have one question.
Yeah. Yeah. Go ahead.
Can we say that this vector is in it's in column subspace of this matrix? So
Column,
if it is in
column subspace. I'm not sure. I'm not right now. I'm not sure. I mean, this is a
because if it is in column space, then we can say that
you can see what you can say basically. When you apply a transformation on this particular vector 1, 2, 3, it is getting scaled up or scaled down. This you can say, but you cannot say it's in column subspace or somewhere. That's what I feel right now. I'm not sure. Okay. One thing is very clear that 1, 2, 3 will be scaled when you you are doing linear transformation with this particular matrix. Okay. So where we talked to Ragini. Sai Vineet.
Sir, is there a difference between column subspace and column space?
No, I think these are the synonymous terms. column subspace. I don't know what is column subspace. It's column space one. Okay, any doubt in this question? Anyone who is not able to solve?
So in question 6, sir, how to find this lambda value? Yeah.
Okay. So see, you will get two particular equations. Okay. So if you used ax equal to lambda x, okay. So you will be having 4, 1, 2, p 2, 1, 14 minus 4, 10, and multiplied with 1, 2, 3. It will be equal to lambda times 1, 2, 3. Okay. Now if you multiply the left side, you'll get 4 plus 2 plus 6, then p plus 4 plus 3, and 14 minus 8 plus 24 equal to lambda times 1, 2, 3. Okay. So see, you can find this lambda equal to 6 plus 6, 12. Okay. From the first element.
Oh, okay, okay.
Got it?
Mm-hmm.
And second element is 7 plus p equal to 2 lambda. So lambda you have, so like this you have to find out.
Okay.
Subspace contains 0 vector. Achha. Okay. So next question. Let's move to the next question. Okay, this is again a easy question. I think two people can solve it. Go ahead and solve. It's a subjective question, so maybe you solve it in 1 minute. So Sai Vineet, we are talking to. You are not audible. Your mic issue. What is there? Sai Vineet. Okay. Sajal Parihar. I hope all these people are there. They are just not logging in. Samit Sen.
Yeah.
Okay, you were already talking, right?
Yeah.
Okay. And then we have Sharmila. Before Sharmila, we have Sankalingam. Sankarlingam. Sankarlingam, am I audible to you? I think we should mark our attendance like this. Otherwise, it is not clear who is there, who is not there. Sharmila P.
Am I audible, sir?
Yeah. You're audible.
Yes, sir.
How is MLF?
It's going good for me, sir.
Great. Any feedback, anything?
Actually, live sessions, I just wanted to tell you that instead of streaming them in the afternoon or can it be postponed in the evening so that we can join without any tension?
It is on weekend, right? I hope all the live sessions are on weekend.
No, sir, I'm talking about Monday sessions.
On Monday there is a session, is it?
This Monday, I don't know, sir. I need to check, sir.
Achha, okay. Okay, so I'll put this feedback through to the team. Okay.
If at all it's possible, like in the evening 7 to 9, like that.
Actually, there are so many subjects running, so therefore this issue comes. So yeah, I'll put this forth to the team. Let's see what can be done.
Okay.
Actually, sir, it becomes difficult for the working professionals.
Exactly, sir.
I mean,
in the afternoon.
We are home by 7:30 or 8. Sometimes we leave office by 8. So it's really tough for us to join the sessions there.
Yeah, very correct. But there is a constraint with the number of subjects that is running with this.
Sir, even for students also, as offline colleges have also started now.
So the thing is, therefore we are having this YouTube live stream. Yes, I understand the live session part has its importance. I mean, if people are live, they can directly ask questions. So I think there is a concept of on-demand sessions. Is it there or not? You can always ask for extra sessions if you want to.
Okay. Okay. But
I
this
think
is request from our side, sir.
that
It
is
should be
taken care,
in
sir.
the evening.
Like what
Okay,
happens is
sure.
we watch YouTube, we watch the session on YouTube, and if we have any issue, then obviously we go to the discourse and try to see the solution there.
Sure,
That,
sure. So
that alternative is
I'll
available.
put this request forward to the team. Okay.
Sure, sir. Thank you. Thanks a lot.
What can be done? Achha, so for this particular question, in the matrix equation Px equal to Q, which of the following is necessary condition for the existence of at least one solution for the unknown vector X? So, what option should be correct? C. Okay, if PQ first, if you see the option B, vector Q must have non-zero elements. It's not true. So your equation can have solutions even if Q have zero elements. Okay, so option B is incorrect. Option C is matrix P must be singular. No, it should not be singular, because if P is singular, then determinant is zero. So determinant is zero. Then matrix P must be square. Not necessarily. There are situations where P may not be square. So the answer is A. Kya Pranav? Good, you find out the correct answer on time. So the answer is A. Okay.
So can you explain why A?
Why A? अच्छा ठीक है. If you have PQ, ठीक है, and rank of P and Q is this augmented PQ is not same. So there are two possible cases. Okay, let's take an example. Let's take P is 1, 2, 3, 4. Okay, and Q is suppose 1, 1. Okay, now the augmented matrix PQ. I have just taken random numbers. Just don't go by the exact calculation will not be there. So if you take augmented matrix PQ, it will be 1, 2, 1, 3, 4, 1. Okay. Now suppose the rank of PQ is not equal to P. Then what can happen? There are two situations. Rank of PQ greater than rank of P and rank of PQ less than rank of P. So suppose now rank of PQ is less than rank of P. Achha, it means 1, 2, 1, then 0, 0, 0. And P will be having 1, 2, 3, 4. It means the solution doesn't exist because you are having an equation where 0x1 plus 0x2 equal to 5. But since you know, if you multiply 0 with anything, you should get 0. Intuitively, is it clear?
Yes, sir.
So can we say since Q should belong to the column space of P, that is why the
that is a more fundamental theoretically right answer. But just I just wanted to give you a practical shot into it. What you said is very correct. Since Q should be in column space of P. Achha. And the second case is agar PQ has greater, then it has infinite solution. So that way you should consider. I mean, just see the example. You can give answer intuitively yourself if you take examples and make it. Achha, we talked to Sharmila, I guess. Next, Sheetal, we talked or not? Sheetal Mishra. There, Sheetal. Okay.
Sir, I have a doubt on this one.
Yeah, go ahead.
Is point A always going to be true?
Yeah, it's always true.
Okay.
Next, Question number 8. Try to solve it. The system of equation then next should be unique solution or one solution, multiple solution, or no solution. Okay, this should be the answer. One, multiple, or no. इसमें से कोई एक आंसर you should get. Next, Somesh. Srinivas, we already talked about it. Srinivas Chillupuri. Sumit Kumar Chauhan. Sumit Kumar Chauhan. So I am very much not sure whether these people are there or not. Venkatesh Sambat Kumar. Vidya. Yusuf Hassan, you have typed many things. Yusuf?
Yes, hello, sir.
Okay. So you are there. How is MLF?
Yes, sir, going good now.
Any particular feedback, anything?
No, sir, not as of yet. The live sessions are great and they are very helpful. So, yeah, if we could have more.
So I've got two answers. They are saying unique solutions.
Actually, for me, live sessions are only helpful.
Don't say this. IIT profs teaching something is of very help. I mean, many people do not get this amenity, right?
Yes.
Live sessions are helpful, but the efforts that profs have put is also
Commendable
in this course. Okay. And yeah, you can always put your feedback through proper channel so that we all can improve. Okay. Next, Hemant. All these people do not have mic, is it? Hemant, Nikhil, Pallavi, Saikat, Shubhi. Okay. Okay, I think we are done.
Sir, how many of them are present?
I'm not sure, but I can always see the video to find out.
Yeah.
Okay, so how do you get unique solution? I will talk to maybe Azhar Guraja, if I am pronouncing your name correctly.
Yeah, actually, we can solve this equation and we will get all the values also.
Okay, solve this equation and get the, yeah, that's the best way. Other than that, yeah,
I applied, yeah,
row echelon form and then find the rank. If your rank and number of this B, number of elements in B is same, then the solution is unique. If your rank is less than rank of C, if PQ and P have rank less than the number of equations, have infinite solutions. And if there is a ulta case, then there is no solution. Okay, so let's move to the next question, question number 9. So we have solved it. It's very easy. Maybe 2 minutes it should take. Okay, other than the people I have directly asked, anyone else who is having any comment, any feedback, any review, feel open to speak. Okay, so what is the approach that you people are using for this particular question?
The AX is equals to lambda x.
Correct. Ax equal to lambda x. Then you have to find lambda. That's it.
Yeah.
So lambda will be 6 from the answer that you are giving. Okay. Next question number 10. I think this is the last question of the session, and this question is just for information's sake. It has nothing to do with exam and all. But it's a very important property that should be remembered. Solve it, and then we are done for the day. Okay, so basically in this question, the options could come up because I could not use clear deck due to some reasons. So basically here you should find the characteristic equation and then replace lambda by E. That's it. And where this property is full is when you are finding the powers of matrix. Where this property is very useful.
And then we can multiply by A transpose also, sir.
Yeah, you can do whatever you like to. For instance, see, suppose I saw a characteristic equation a square plus a plus I.
Yeah.
Okay. I mean, sorry, characteristic
Sir, I think
equation.
here it is coming a square plus 3a plus 2i is equals to 0.
Okay, what it is coming? Lambda square plus?
Sir, a square plus 3a plus 2i. I mean, in the lambda form, 3 lambda plus lambda square plus 2a plus 2
So
equal.
what is the lambda equation? Instead of lambda, put a and
yeah.
instead of put I.
Yeah. So I got a square plus 3a plus 2i equal to 0.
So now suppose you want to find a raised to 4.
Yeah.
So what you will do? See, a raised to 4, if
Sir, I'll multiply by a square.
Yeah, so what you will do, you just take a square. A square will be 3a plus 2i.
Yeah.
Okay. So what you have basically done, you have a square. The square term you have converted to a linear term. So adding is always easier than finding product, in case of matrix at least.
Correct. Yes.
So now a square. Now you have to do 3a plus 2i into 3a plus 2i. Wahan pe bhi you will get a square term. And that a square term is again 3a plus 2a.
Then we can find a also. 3i plus 2a transpose.
That way the computations become very easy. Okay.
Sir, so this will come in the coming week or?
No. This is just out of scope of the syllabus. So extra material. It has no significance with respect to your exams and marks.
It's not related with ML also.
It's related with matrix. It has nothing to do with machine learning foundation as a course.
Matrix. Okay.
It's a very important property of a matrix.
Yeah, carrying a meter. I heard of it.
Okay. So I think we are done for the day. Any feedback, anything that you want to give, you're welcome. Yeah, we can easily find inverse with this too. Correct.
Sir,
Yeah.
sir, for question number 6, if you could go back.
Question number 6. Okay.
So when it was said that since the definition of an eigenvector, it needs to be in the same space and it needs to be scaled, so that way of solving that it needs to be part of the column space should also work, right?
I'm not getting it exactly.
Sir, a definition of an eigenvector is it should be part of the same space and it should scale. It should not change direction by definition, right?
Yeah. It should not be. It should not change direction in a sense. It should be in the same line. Basis of that vector doesn't change.
Direction should not change, right? It should be either parallel or anti-parallel.
Yeah, correct.
Plus, it should be initially it should be part of the space, right?
See, if there are two vectors which are not, if there is a matrix and a vector which are not in same space, you cannot multiply them simply.
No, sir, yes. I'm not saying that. For this vector should be in the space created by the matrix, right? Initially, for it to be an eigenvector by definition.
Created by matrix. Yeah, again, I'm not sure. Yeah, you asked me this question again. I mean, second time, right?
No, somebody else asked the question.
Yeah. I'm not sure about this. I have to maybe think about this, then I can answer.
Sir, and one more request, if you could go into full screen mode, we are all doing it on, some people are doing it on mobile. It would be easier for us.
Achha. Sorry, you should have told me this before.
Next time.
Yeah, so you should have told me this before. I didn't realize it.
No, sure. That wide wala button and full screen possible.
Yeah, I didn't realize it. I would have gone full screen. Okay.
See you, sir. Thank you, sir.
Yeah, thanks a lot.
Okay.
Thank you all of you for joining this session.
And sir, thank you, sir, for covering 2 weeks. That's really great. Yeah.
So,
Sometimes एक भी week cover नहीं हो पाता. आज 2 week cover हुआ. So yeah, that's great.
Okay, thank you. So please feel free to have feedback too. I will get feedback from the team. So you can put on Discord wherever you like to feedback of the session. Okay.
Okay, sure.
Sir,
Yeah.
Sir,
I just have one thing to say. Sir, for week 3, question number 8. Sir, can you just do that on the discourse? Sir, I just want to look at the solution.
Okay, sure. I will tell my team. Someone will surely do and put, because I do not have access to discourse directly right now.
Okay, sir. Thank you. Yeah, that will work.
Okay.
Sir, one more request can I?
Yeah.
Yes, sir. So जैसे maths वाले में हम लोग ट्यूटोरियल देखा करते थे, that used to be very helpful. तो यहाँ पे भी कुछ ऐसा होता तो मतलब पूरा लाइव सेशन हमेशा नहीं देखना पड़ता, ऐसे पूरे लाइव सेशन को ज्यादा देखना पड़ता है, लाइक 3-4 लाइव सेशन होते हैं हर वीक. तो कुछ वैसा ट्यूटोरियल
can also put मतलब tutorial, you mean जो the supplementary videos that
yes sir, like जैसे कि ये क्वेश्चन सॉल्विंग हो रहा है तो कुछ होता था ना मैथ्स 2 तक में भी कि हाँ कुछ क्वेश्चन.
Actually the thing is we have also we are planning for this for a very long time, but somehow we are getting very much stretched, so we are not able to do that, but for sure we will try to. Therefore we are having extensions in this subject.
Yes sir, उससे होता क्या है कि सर ऐसे जैसे कि हम लोग को कहा जाता है कि 10 आवर्स देना है एक सब्जेक्ट पे, तो 10 आवर्स नहीं हो जाता है, वो तो जाके 20 आवर्स पे खत्म हो जाता है, क्योंकि 6-8 घंटे तो लाइव सेशन का ही हो जाता है, तब 2 घंटे का कम से कम लेक्चर रहता है, 2-2.5 घंटे का, तो ये सब देखो फिर असाइनमेंट्स वगैरह रहता है, सो इट यूज्ड टू बी वेरी हेक्टिक.
We will try to improve the tutorial quality.
Yes sir.
Sir, will we have further sessions like revision ones?
Yeah. Before every quiz, you get a revision
Yeah,
session.
that will be so possible.
Yeah, that will be very helpful, I think.
Yeah. That is always there.
Yeah,
Before every
that is
quiz,
always there.
it is always there.
Yeah.
And we are very ready to help you. Even on discourse, our team is very active.
Yeah. Sir, वो tutorial वाला बस एक बार
Tutorial I'll give.
Yes, please. क्योंकि इससे होता है कि कॉलेज वगैरह या वर्किंग प्रोफेशनल लोगों को भी थोड़ा हेल्प हो जाता है थोड़ा.
Okay. Sure.
Yeah.
Okay.
And
Thank you,
sir,
thanks.
one small question can I ask? Sir, if the eigenvalue of the matrix are distinct, then its eigenvalue are linearly dependent. It always true, right?
Linearly independent.
Independent, right? Yeah.
Not dependent. Independent.
Yeah, independent. That's what it is.
That's true.
Yeah. Okay, sir. Thank you so much. Beautiful session.
Yeah. Thanks a lot. Feel free to have feedback on discourse. Bye. Take care, all of you.
Thanks. Bye.
Bye.